Okay, so now we're going to talk about other phases. So we've shown gases over and over and over again, but we can do equilibrium constants with some other, or for reactions that have mixed phases. So, it's known as heterogeneous equilibria or heterogeneous equilibria. No, that's not right. Heterogeneous equilibria, that's what it's called. So, for example, if we have solid carbon reacting with CO2 gas to give us 2CO, carbon monoxide gas, not a reaction you want to do in a confined space, by the way, that's for sure. Couple breaths of CO, you're unconscious, couple more, and you're dead. So you want to watch out for that. But how do you get a concentration for a solid, right? We need concentrations for something like Kc, or how do you get a partial pressure for a solid? That doesn't make any sense, right? None of it makes any sense. So the answer is we don't include it in the expression at all. So solids are not included. So when we write the expression for this equilibrium constant for this reaction, carbon is not in that equilibrium expression. So if we write Kc, we go product squared over reactant to the power of 1. This guy doesn't show up. No solids are used. And it's the same deal with liquids. So pure phases like solids and liquids, they don't have concentrations. How do we use them? We don't. So essentially it's like it has a concentration of 1, and so it's just invisible. You don't have to write it. What's 1 squared? 1. What's 2 squared? 1. Oh wait, hold on. No. What's 1 cubed? There we go. Whew, getting late in the day. I'm going to blame my toe, whatever. So what's 1 squared? 1. What's 1 cubed? 1. What's 1 to the power of 1? 1. What's this thing times 1? This thing. So we don't have to write it, because why bother, right? Same with liquids. We can just treat it like a 1. We don't write it in the formula. So we've got liquid H2O over here as a product. Different if it's a gas, we can use it. So water vapor can show up in equilibrium expressions. Liquid water does not show up in equilibrium expressions. So we have our other product to the power of 1, bing. We have reactant to the power of 1, reactant to the power of 1. That is our expression. So it'll be carbon monoxide over carbon dioxide times concentration of H2. So we can get a Kc expression here. And kind of the big takeaway is, so only gases and aqueous species are used in these equilibrium expressions. So no solids and no liquids, because we cannot measure concentrations or partial pressures for them. So it doesn't make any sense. They don't zero out, they 1 out, if that makes sense mathematically. You multiply by something by 1, why'd you bother even writing multiply by 1? It's the same thing, right? So that's what we're doing. All right, so this is how we handle it. I don't think there's much aqueous stuff in this chapter. They really save it for the subsequent chapter, so it's more of a 223 thing, but just an early heads up. Liquids and solids don't show up, and that doesn't change. This isn't one of those things where we move the goalposts on you. It is going to stay the way it is. So do not write solids, do not write liquids in your equilibrium expressions. So when you calculate them, you just leave those numbers out. Not that there's numbers for them anyway, right? So you leave those chemical species out. All right, so we're going to get started on Le Chatelier's principle, which will be a couple videos. We'll break it down, variable by variable.